Another example of solving a right triangle. The orientation is a little bit different, but technically that doesn't even matter. So let's label our right triangle. This is the right angle. This side has to be C. The other two doesn't really matter, just call one A and the other one B. And let's put in our information that we're given. Angle A is 67 degrees, so I'll put that here. And that is this angle at that vertex. Side B is opposite of big B, so that's going to be this side over here. So this will be 50 centimeters. And since we're solving this, we want to find all the other sides and all the other angles. So the first one is easy with this one. We're going to go for the other angle. 67 taken away from 90, that'll leave us with 23 degrees. But again, just like before, I'm not going to use this angle to do anything. I want to use just the 67 and the 50. Alright, so let's say I'm looking for this side over here. Let's call it C. It's opposite big C. If I'm looking for C with this angle, and I'm given this side over here, I'd like to give it a name. So if I was going to name it, that side would be adjacent, because this one is the hypotenuse. So here we have the adjacent side, here we have the hypotenuse side, and that's the one we're looking for. So the function that works with adjacent and hypotenuse is going to be cosine. So we're going to figure out cosine of the angle, which is 67 degrees, is equal to adjacent over hypotenuse, so that's going to be 50 centimeters divided by the hypotenuse, in this case letter C. Alright, to solve this one's a little bit different. We could do it the long way this time, and then I'll show you a shortcut. Whenever you're dealing with an equation and you're solving for the variable in the denominator, or for that matter any equation, you want to get rid of the fractions by multiplying through by the common denominator. In this case it happens to be C. So if I multiply both sides by C, I'm going to get C times cosine of 67 degrees is equal to 50. And finally, to solve for C, I'm going to divide both sides by cosine of 67. So we're going to have 50 divided by cosine of 67 degrees. Alright, if we type that in our calculator, we're going to get 128 if you round it. So C is approximately 128. And what I mean by rounding, it was 127.96. So it just rounds up evenly to 128. To show that, I'll put 0.0. The measurements is centimeters. So the hypotenuse over here is 128 centimeters. Alright, so that leaves one last side, this side over here. So we'll be looking for side A. Opposite of big angle A is little a. So to find A, we're going to use the given information. I don't want to use 128 because it was approximated. So I want to use 67, the adjacent side, and this side. Well, this side is opposite of 67 degrees, so this will be the opposite side. And I want to use opposite, and over here is the 50 centimeters, which is adjacent. And opposite and adjacent is the function tangent. So we're going to set up tangent of 67 degrees is equal to opposite, which is A, the letter we're looking for, over the adjacent side, which is 50. And this one's the easier one to solve. Multiply both sides by 50 and you get A equals 50 tangent of, 50 times tangent of 67 degrees. And if we type that in our calculator, we're going to get approximately 117.8 centimeters. So the third side over here is 117.8 centimeters. And we've solved the right triangle. Now that shortcut I was talking about, if you come back up here where we multiply both sides by C and then divided by cosine of 67, basically all that happened from this step to this step was you interchange the denominator with the opposite side. The cosine of 67 replaced the C replaced the cosine of 67. So if you see that, it's actually a law of proportions where you can flip on the diagonal if you set up two fractions here. But it's a nice little trick to know when you're trying to solve for the variable in the bottom in these situations.